Hi, in this video, we're going to look at stateful DHCPv6 configuration. And again, these slides have been pulled from my book on IPv6 fundamentals and my live lessons video series. So if you're interested in either one, please check those out. A lot of good information in both. Okay, so we've looked at in prior videos, method 1 and method 2. In this method here, method 3, we're going to look at how to configure a router to be a stateful DHCPv6 server. And what this here is showing is that in the router advertisement, so the router is going to send out an RA message. That's done only because we have this command here, IPv6 unicast routing, which actually turns the router into an IPv6 router and will send out the RA message. And the RA message, there's 3 options as far as dynamic configuration of hosts' IPv6 address information. Okay. The default is slack. Another method is slack plus stateless DHCPv6. And in this video, we're going to take a look at stateful DHCPv6. Basically, this is very much like stateful DHCPv4. The big difference is that devices will not receive their default gateway information from a stateful DHCPv6 server. It can only get that from the router advertisement message. All right, let's get started and take a look at this. So the router acting as a stateful DHCPv6 server, we have the client asking for a router, sending a router solicitation message, which means it's asking for a router advertisement message. How do I obtain my addressing information automatically? In this case here, we have the A flag is set to 1. We're going to talk about that more in a moment. The O flag set to 0, it's off, and we've set the M flag to 1. Okay? Well, what this means is that the host, with the M flag set to 1, we're telling the host to create its IPv6 address, that the M flag set to 1 to receive its IPv6 global unicast address from a stateful server. But this A flag is also set to 1, so we're also telling it to use slack. So let's take a look at what this will cause. Okay. All right, and then I'm going to explain how all of this works. All right, so just a reminder, these are the DHCPv6 messages, similar to what's done in DHCP for IPv4. The client sends out a solicit message looking for the DHCPv6 server. The router advertises itself, or it doesn't have to be the router, but in this case, we're going to be configuring the router to act as a DHCPv6 server. The DHCPv6 server will advertise itself as a DHCPv6 server. The client will then request information from this, usually the first advertised message it receives, and then the router, in this case, whatever DHCPv6 server it chooses, will send back a reply. Okay, let's take a look here. So first of all, how to set that M flag to 1, okay? To set the M flag to 1, it's 0 by default. We use the IPv6 ND managed config flag. That sets the M flag to 1. Okay? Basically, we're telling the device that it needs to get its global unicast address from a stateful DHCPv6 server. Okay? Now, what if this is a Windows host? Okay, if this is a Windows host, this A flag is also set to 1. So what it will do is say, hey, I'll create, because you've got the M flag set to 1 here, this device will say, I will get my global unicast address from this server. But you've also told me the A flag is set to 1, so I will create one using slack. Okay, so we'll take a look at how to keep this from happening, what you should do. Oh, here we go. So this is the consequences of when you have the M flag and the A flag set to 1. Notice that your device gets this address. Actually, this is the address from the stateful DHCPV6 server, and I can tell because I'm using deed here. I'll explain that in a moment. But it will also create an address from Slack, because the A flag will create its own address automatically using router advertisement. And if it's using the privacy extension, it will create a temporary address as well. That's because of Slack. Talk about this in more detail in the book and also in my videos. But anyway, this is why you get so many addresses on Windows. Okay, but what if we just want one address from the stateful DHCPV6 server? Okay, let's take a look at how to do this. We need to set that A flag to 0. Okay, so we set the M flag to 1, meaning we want it to get its address from the DHCPV6 server. To set the A flag to 0, we use the ND prefix, IPv6 ND prefix length, no autoconfig. I'll show an example of this in just a moment. Okay, but let's see the results of this. So here's the router advertisement message. Okay, so the router advertisement message includes the prefix and prefix length. The managed config flag is set to 1. Telling the device to get an address from a stateful DHCPV6 server. So the device receives the router advertisement. It's going to use the source IPv6 address for its default gateway information. Sees the managed config flag as 1 and says, okay, I'll go ask a stateful DHCPV6 server for my IPv6 address, which it will do. Okay, but if it was a Windows host, it would also, and if the A flag was set to 1, it would create another address using Slack. Okay, so if the A flag was set to 0 by default, it would create its own address, a second address using Slack. So we want to change that to a 1. So let's take a look how to do all this. All right, I'm going to come back to all this in just a moment. These are the syntax, but I want to show you the actual commands. Okay, so this sends out the router advertisement. Okay. We're on this gig 00 interface. Actually, I've noticed a little mistake I have here. This should be a 1 since we're doing a 1 here. Okay, that's all right, Rick. Managed config flag, all right. We're going to have this device act as a stateful DHCPV6 server. Okay, again, I say IPv6 IPv6 stateful upper caps, that's what I'm calling the pool. And here's the pool information. So let's take a look at some of this here. So, first of all, this is the M flag set to 1. So this is the M flag set to 1. This command here, IPv6 ND prefix, we're saying we're sending out this prefix and prefix length in the RA message. No autoconfig. This means set the A flag, we're setting the A flag to 0. That tells the device, do not use Slack. So those Windows devices won't create their own address using Slack because they're going to get their address from the stateful DHCPV6 server, which happens to be our router. Here it is. Here's the stateful DHCPV6 server. Here's our client. There we go. That's the client. That's the server. There we go. All right. So when the client sends out the discover message, this router says, I'm a stateful DHCPV6 server. Matter of fact, I'm going to allocate addresses from this pool. I'm going to give you this DNS address and a domain name. But this is the command, address prefix command. This is what makes this router a stateful DHCPv6 server. Basically, we are going to allocate addresses, or this router is, that has the first 64 bits, 2001 DBA Cafe 1. And then so we can keep track of them, the interface ID of 64 bits is always going to begin with the first 16 bits of deed. That's just so we know that that address has actually been allocated by this server. Okay. There is no excluded addresses. So let me talk about that. So in DHCPV6 on the Cisco iOS, we do not exclude addresses. So a router can give out any 64-bit interface ID. That's 18 quintillion possibilities. What's the possibility of it giving out one that's actually being used by another device? Pretty darn small. 18 quintillion possibilities. What's the chances you gave it the printer's address by mistake? Pretty small. But, so by default, you could actually allocate any of these. Let's me back up here. Anything from quad 0 to quad Fs for your interface ID. So if we were to say address prefix and just 2001 DBA Cafe 1 and not include the deed and just make this a 64, like I'm showing here, then any of these could be allocated. Okay. But if I want to be a little bit more cautious, or in other words, I actually want to know when a device received its address from this specific stateful DHCP server, I'm going to preface the first 64 bits of my interface ID I hand out with deed. So everything will get something beginning with deed. All other addresses are excluded. This is the only addresses I'll be handing out. So we've excluded everything with the first 16 bits beginning with anything else. All right. And we can see here, yep. So there it received the default gateway address from the router advertisement. All right. There's our IPv6 address that it received, and there's the deed. So it got that from, and the other information from the stateful DHCPV6 server. And again, our M flag is 1, and we set the A flag to 0, so it wouldn't create an address using Slack. So when we do the show IPv6 interface gig 00, in this case I've got 00 here and 00 there. That's okay. I guess I should have used 00 before. That's all right. We can see, whoops, we can see, I'm too fast here, right here. It's hard to see here. It's telling us host use DHCP to obtain routable address. That's the global unicast address. Okay. All right. And if I do ipconfig/all, we can see it right there along with any lease information. All right, so for more information on IPv6, you may want to check out the book or video. Anyway, enjoy. Thank you.